Hi, folks. Welcome all of you for a session on Introduction to AI and Machine Learning from CloudxLab. Let's get started. So, in the first session, we're going to set up, just tell you what it is. So, the agenda will take about 3 hours. I'll tell you about CloudxLab, about the new ILT, the new instruction-driven, instructor-led course, machine learning course, which we have done, about the speakers and the instructors who have built the course. Then we'll have a session on what is machine learning, what is the machine learning approach, what is AI. We will regularly have Q&A sessions. We'll keep answering the questions as it comes. We will have a short break somewhere midway. It's a water break for you, for me, for everyone. And we will do and after that we'll continue again, and we'll have a little more discussions on machine learning types. We will then discuss what are neural networks and what is AI, and how neural networks today powers AI. So again, let me explain. As I said, this is an open session. It's in YouTube. It's open for everyone. In today's session, except me, the instructor, everyone else is on mute. You can't talk. In case you have questions, you can use the YouTube chat window to chat and to ask questions. We have our support engineers and marketing people who can answer any questions you have on the chat. And I will also be taking questions on a regular basis. Please, the attendance sheet will be shared with you. Please sign up for the attendance sheet. In post that, the recordings and the slides will be shared with everyone who's attended it. So people who attend it, we will also have some specific uh, prizes and surprises that we will reveal during this lecture. So just keep your eyes open. Okay, so let's get started. Okay, so the instructors of the course are Sandeep Giri. So Sandeep Giri is the founder of CloudxLab. He's got a lot of experience with Amazon in MobiD shop. He's one of the key instructors. Abhinav Singh is also a co-founder CloudxLab. He's got a lot of experience in edutech and game development, and has been instrumental in building the user feedback and the gamified experience at CloudxLab. He's also a part of of the course, and he has designed a lot of the content. The guy in the middle is Praveen, that is me. So I am giving you today's lecture, and I've also contributed towards this class. So I am a co-founder and CTO at Yathis. So my interests have been IoT, ML, computer vision, and the edge. I have graduated from IIT Bombay with a dual degree in electrical engineering, and I have a few patents and conference papers to my credit. Okay, so now I'll talk about the machine learning specialization course that we are now will start running soon. So it's an online instructor-led training course. So there is an instructor. There'll be about 250 hours of blended training that includes recorded sessions and online sessions, which are held every week. There will be 240 days of the CloudxLab, the Cloud Lab access. So you could access and practice for about 240 days. That is a fair amount of time, almost 8 months. Then we also have actually 18 plus, not 18 plus, actually today we have 21 plus real world projects, gamified projects, which you can try and see how it works, etc. So that's something which makes CloudxLab really unique. We've got automated assessments and quizzes. Uh, as a part of this course, you will get lifetime access to the course content that includes the videos, the slides, and video slides, and any other material. You would get a verified certificate, and during the course of the project, there will be a support to answer your questions and doubts, both during the weekend sessions and regularly as and when you access the LMS, the learning management system, at your time. That's also is possible. So some more highlights. So we've have a few seats left next batch. We have a batch running right now that started on the 5th of December. Our next session is starting on the 10th of January next year, and they're filling fast. So they will happen on between 8 to 11 p.m. IST on the weekends. And like there's like this slot, exactly the same slot. And the price is given here. It's 4699 for in India and 649 US dollars outside. The link to enroll is also given over here, and you could use that. Okay. So what's more? So as a part of this of our course, we also running a scholarship test. Okay, so scholarship test will get you. So people who qualify to the qualified test will get a 30% discount on the course. That's happening on the 20th of December between 4 to 6 p.m. So you could people who are interested, please give a shot. And in case you have already if you've already bought the course and you get the scholarship, the money, the 30% amount will be refunded to you. So I would encourage all of you to take the scholarship test and see where you stand, etc. Okay. Yeah. So I'm going to tell you about CloudxLab. So CloudxLab aims to make learning fun and for life, accessible everywhere and in fun. So we got videos, quizzes, hands-on assignments, and real-life projects, along with case studies. So holistically, it's a complete platform where you can get a lot of real life experience, real life like learn hands on. It's just not a theory course, it's a really hands on course. There's a lot of content for videos, and for with along with the lab there's a lot of content which you can get your hands dirty on with real code. That's great. So the Cloudix Labs platform looks something like this. Okay, so what we have is you will have a section on your left hand side where you will have content, and you will have instructions, etc., which you're supposed to do. And you on the right hand side you have what's like a playground. So in the playground you can type the code. Okay, you can type your code the playground, and you can press submit answer. And when the answer is submitted, the assessment platform, which we call AHA, checks what you've written and disagree and checks what you've done and what you've done is correct or not. If it's correct, it's going to congratulate you. You'll get some points which will incentivize you to keep going forward. In case you get it wrong, you got access to hints and answers, etc., which you can do. The other nice thing that we have access to is that we run some a forum, a comment section where you'll have a lot of students interacting with each other, and who post questions, and the answers get answered by the students and by the teaching assistants and the engineers at Cloudix Lab. So this is available as a part of the Cloudix Lab platform. So Cloudix Lab, as he mentioned, it's an online cloud-based platform. It comes with pre-installed tools and software for practicing AI, machine learning, deep learning, data sciences, big data, everything that's related there. It looks like this. It's a Unix-based platform, and you get hands-on access to Unix and the entire platform. So this is very much like what you would get if you join a company. You would get access to a ready-made platform. So the nice thing about this is that it saves you from the agony of having to install all these different software on your personal laptops, which for one can be time consuming and also a little daunting in the beginning. So this kind of makes it easy. It makes it really easy for people to get started quickly. And in the end, if you're working on in a company, you typically get a ready-made platform from the company to work with. So this is as close to as you would get in a real job. So summarizing, so we are Cloudix Lab has an online cloud-based lab. You get real-world experience. You don't have to spend too much time in installations. You got access to central data sets. from which you can just copy data and process it, test it, learn some exercises. It is accessible by a browser, so you can connect from any device anywhere with any literally. So if you could be on a Mac with Safari, or you could be on an Android tablet with Chrome, or a PC anywhere, and you can access the CloudxLab platform either via browser or SSH, and learn anywhere at your convenience. The other thing that CloudxLab really does is there's this whole social interfacing where you kind of are interacting with your peers. That is what we call social proof. You could there are modes of interacting with the other people who are studying. There's a leaderboard that shows where you stand in the class or among all the students. And this again, it we have these modes in which people can interact with each other. You can ask questions and get replies from people. So this is a great way of studying it, and in some ways we try to simulate a real class experience. So Cloudix Lab also has hiring partners and a dedicated job portal. So people who are interested in upgrading their career, enhancing salaries, etc., can come there and take a look at the job portals and our hiring partners, whom we make introductions to. And this is also something that's available as a part of our platform. Okay, now let's get into the subject matter here. So question is, what is machine learning? So machine learning, Arthur Samuel in 1959 specified machine learning as a field of study that gave computers the ability to learn something without being explicitly programmed. So now let's try to understand that with a real use condition. So the use condition we'll take up is a game called Mario, which I presume a lot of you have played. So in Mario, you have this pudgy Italian plumber Mario and his brother Luigi, who are in this mushroom land, and they have to rescue a princess. And they are on a conquest. In the conquest, they have points to get, and at the same time, they have to avoid evil creatures like a few turtles and crabs that come around. So, I presume you've played the game and you have won this. Now, can computers also learn to play this game by itself and win? And can be automated. So we can have a program that learns to play Mario. So what it does is it observes the game and presses keys randomly. And it presses the keys and looks at the outcome, and it tries to maximize the score maximize the score. And so if an outcome gives it takes it if a particular action gives it a higher score, it says, hey, that is nice. And in case a particular outcome results in it dying, it knows that's a bad step. So what happens is that it keeps trying this and doing it. So what we're going to do is we're going to see a demo of Mario playing. So in the beginning, when it's playing, it's just pressing keys randomly, and really nothing is happening, and eventually just dies of old age. Now, give it some more time. Now it's playing a little better. As you would see, it starts moving around. It can do something, and it's able to do some analysis, and it's getting a little better consistently. It gets stuck at places, and then some more time, and it really starts getting better. So now let's watch Mario do something interesting, and it's learning to avoid things. It does a few random jumps here and there, but it knows how it's supposed to tackle the turtles, and even access couple of the more difficult ones. Let's see if it can do this one. So yes, so it's already learned to do some of the difficult ones. It's able to move pretty good. So it's able to go ahead and get better and better. So a few more weeks and Mario now is really hammering it. He's really got good at it. Okay, so what we're going to see is that Mario is going to be start exploiting some bugs, which just because it just tried so many things, It's figured out. So you just notice what happened there. Just notice what happened there. Mario took this jump, just came down slightly, and still could just uh, actually kill that particular tortoise. So that's something that's almost, it's not very obvious. It's like a bug which Mario found. Now it's not the only one which this tool found. It actually found more of such bugs. So let's take this one. It looks like it's going to fall, but no, Mario didn't fall. How did it do that? So it just figured out that it just found certain things to do. So these are certain signs of excellence, of intelligence which Mario had. Just gonna sign. So this is how the game. So the Mario basically, so the program could learn to play Mario, and it could learn to play other games also without explicitly programmed to do so. So now, if this particular program has to learn another game, like say Tetris or Pac-Man, what do you think will it have to do? Will it have to write new rules for the new game, or just hook it to the new game and let it play for a while and learn it by itself? What do you think is right? The first option or the second option? Please let me know on the chat. Okay. So it is going to be the second option, because it's just going to learn to the what you have is a system that's called a reinforcement learning based system, and you can just hook it up to a new game, and it does the same thing, just tries lots of things and learns to play a new game. So you don't have to explicitly program the tool to play a new game. It just figures how to do it. Now this is the same thing we're going to do, but we're going to do it for life. We're going to gather data and then automatically solve problems. So in fundamentally, what everybody's really trying to do is been trying to predict, and we've been trying to do this since ever, since humans were our early ancestors were on the large savannas, and they were hunting for prey. They used to look at they used to look at the stars and try to figure out patterns and try to find out things that it could help them. In a while, they started figuring out patterns to seasons, etc., that helped them figure out when to plant, when to plant, the early ideas of agriculture, to figure out the patterns of how animals migrated for them to hunt. Well, even astrology came out of the same thing, where you can see people try to see patterns in the stars and try to predict how our future would look. So we've been trying to predict things from day one, gather data and predict things. The same thing. So manufacturing industry today is also trying to predict. It's trying to predict what products to manufacture, which processes must be optimized, what is the best price to be, how do you price a product, shouldn't be too high, it shouldn't be too low, all that they're trying to do. The agricultural industry is one of the biggest ones. Agri-tech is really taking off. It's trying to figure out which crops to grow, what will the prices of the what how should the prices of the produce be, what processes to follow, etc. They're all trying to figure out. The healthcare industry is trying to predict. It's trying to predict a disease based on its systems, on the symptoms. It's trying to see which drugs are most effective. It's trying to figure out how pandemic can be stopped. Right now, there's a lot of analytics running into figuring out. They're trying to figure out what was the pandemic we were seeing, how it spread, and now how do we deliver vaccine on time. A lot of places, there's a lot of work happening there, and so this is something which is is prevalent in all industries. So every industry is trying to predict, and it's trying to predict it by getting more data. So now let's talk about what's happening today is like a machine learning tsunami. We have self-driving cars on the road. The Netflix movie recommendation systems are also driven by machine learning. It's trying to uh, it studied what you like. It tries to figure out what other people have liked, and it tries to figure out what you are most likely to watch. It's trying to keep you hooked onto. It's trying to improve your experience on Netflix, YouTube, Amazon Prime, whatever you watch. The same thing's being driven. The recommendation engines behind that is doing the same thing. Amazon product recommendations also driven by the same idea. It's based on what you've bought, what you've liked, etc. It's trying to show you the next product which you're most likely to buy. This is something which it's doing. The what Amazon is trying to do is Amazon is trying to maximize its revenue by showing you a product which you're most likely to buy. Google search uses algorithms. It's trying to it's once you if you put in keyword, it's trying to figure out based on your past history what link would be most relevant to you. So the link that is most relevant to you is placed at the highest so that you can get access to it and you don't have to spend too much time looking for stuff. The speech recognition systems which are on your smartphone or on the smart devices like Alexa's, Siri's, etc., the Google Home, they also use speech recognition, which is again leverages machine learning. So machine learning is everywhere. So what machine learning is trying to do is it's trying to get data and then intelligence on top of it and help you make your lives better, try to solve problems for you. So what does it do? So it basically gathers data, collects a lot of data, then there's a process of cleaning the data and then processing it. Those are the steps of that's the process of gathering data. And now how do you collect data? So now one of the big reasons why there's a machine learning tsunami is that there is just a lot of digitized data around. Everything we do is quite easily measurable. There's a lot of IoT devices, phones, they're all getting cheaper, they're faster, they're smaller, they're accessible at all locations. You've got CCTV cameras that are everywhere, ubiquitous now connectivity at any given time. You got access to Wi-Fi, LTE, soon 5G, GPS, etc. So all that is just there's a lot of data that's available. Now, all that data is you could stream all the data, put it all together at some points, and do very interesting things. Aggregate the information, clean it, and do a lot of things. And if you have really lots of data, it's possible to do parallel computing. And so you could basically take piece of large problems, split into smaller subtasks, and do it across, solve it across a group of network computers. And I mean, in the end, their goal is one common one. So there are tools like Hadoop and Spark that do that very well. So now let's talk about something more practical. So in case you want to write a spam filter, and what we're going to do is we're going to compare an older method, a traditional method, versus a newer ML method. So in the older method, what would happen is you would study the problem, you would write the rules, you would write some rules, you'd evaluate. If you're not happy with it, you would go and analyze the errors, change it, and you would launch it. So a traditional approach, what it did is that an email comes in and then you would look at either the subject or the body, and it would be checked against a set of rules. So rules would be that checked if you see the word credit card, free credit card, or the word free, the word amazing, etc. And there's a rule would be built and said, hey, if you see these words at a particular frequency, put that into the spam bucket. That's a normal way to do it. The other ways would do it is that you could have filters based on certain email addresses. So you know that okay, a certain set of email addresses has been flagged as a spammer, so a particular email coming from that particular address would automatically go into the spam folder. So this is the method of writing the rules. So you would basically have incoming emails and a bunch of rules, and based on the bunch of rules, each email would be going towards two sections called spam or ham. Give spam or ham. So yeah, sorry for the break. Spam or ham. So depending upon however you want to do that. So yes, now what are the problems with this method? One of the problems with this method is that you just start having a lot of rules. Okay, you basically start work. So basically, you basically have a lot of rules. The rules just keep increasing. So people could do something. So for example, now what in this traditional approach, what happens is that eventually the spammers kind of start figuring out, okay, the word amazing is getting flagged off as spam. So let me just change that to fantastic, and that breaks down the existing rules, and a certain set of emails start coming towards the ham ones, and the spam filter is unable to catch them properly. This is a problem that happens in this case. Now, using the ML approach, what happens is you don't write rules explicitly. You basically have a lot of data. So you have a lot of data, what we call labeled data. So label data. What does label data mean? Label data means you'll have a lot of emails, and you'll have some emails marked out as spam and some emails marked out as ham. And what happens is that you would have an ML algorithm that would study this, and it would try to figure out a pattern, a bunch of rules internally to the ML algorithm to say, okay, these are spams and these are hams. And that's what it would run. So it turns out to be a more robust method. At the same time, it's an online method that keeps going online and online. It is not something that just keeps growing automatically. So today, almost all ML algorithms, or all spam filters are largely driven by ML algorithms, and not by the traditional rules-based approach. Okay. So what is AI? A lot of you would have heard of this term called AI, and so it's basically the intelligence exhibited by machines, not by humans, not by animals, but machines. So it's the theory and development of computer systems that to perform tasks that normally require human intelligence, like visual perception. This has been one of the biggest drivers of AI in the recent years. Computer vision and visual perception has been something that really drove it. And speech recognition, that's huge. Decision making, to taking existing skills and decision making. So we'll be seeing a few examples today at very high levels that show some of these things happening. Translation between languages is another big example of where AI is being used automatically. So let's talk about a little bit evolution of AI, the history of it. Okay, the history of it. So in every lot of mythologies, like for example, in the mechanical man in Greek mythology, there's a guy called Talos, who's a mechanical person. In early science fiction, you have Mary Shelley's Frankenstein. In recent years, we have the Terminator series. Actually, we have a lot of movies that talk about AI today. The Terminator series was really big one. So we are fascinated by the idea that we can create things that can behave human. That's some of the things we've had this fascination for the longest time. So actually AI as a field is fairly old. So it was coined way back in 1956 by John McCarthy, Marvin Minsky, Claude Shannon, and Nathaniel Rochester. Excuse me. So they define certain sub objectives of AI, like perception, reasoning, navigation, natural language processing, to capability to represent knowledge. And they said all of this put together would be artificial intelligence. This is one of the perspectives people had. Let's just have define what are sub objectives of AI, like perception, reasoning, etc. And if everything is done together, you would have artificial intelligence. So reasoning is like the capability of so if you put everything, then the machines will reason and do some smarter things, like being able to play a puzzle game like chess, Mario, Go, solve geometry problems, diagnose diseases, etc. So navigation is another big issue where AI is solving. Uh, Self-driving cars are quite close. So the problems are, how do you plan and navigate in the real world? How do you locate the destination? How to pick up a path? What is the shortest path? How to avoid obstacles? How to move? How to not have accidents, etc. There are a lot of these issues which navigation AI resolves for navigation. Natural language processing. So the issues are like how to speak a language, how to understand a language, how to make sense out of a sentence. These are other issues uh, which AI is solving right now. Perception is a very important issue with AI. So the it's about like humans, the kind of things humans can do, which even babies can do in the real world. They can we can see, we can smell, we can touch. All that information can be is taken by our brains. We process it and we're able to perceive things. We are able to have a mental picture of what the world is. This is something which people have been trying to recreate for computers. So tomorrow I will, yeah. So now that comes to a concept of generalized intelligence. So with the blocks which you've spoken before, the idea was that if you did the previous blocks, like being able to do natural language processing, be able to do vision, be able to do reasoning, be able to figure out navigation, they believe that the for other things just come out automatically. Emotional intelligence, creativity, reasoning, intuition. So it was expected that if you just get all these blocks together and build a really large system, you would automatically get the next set of intelligence of or what human intelligence, like emotional intelligence, creativity, reasoning, intuition. That was what people have believed. Now today, how AI looks like, AI is like an end objective, and it's so there is software in it and there's hardware. So like an entire system would look something like this. You would have a section with hardware and robots on the other side, which is essentially interacting with your external world, getting data, in some cases actually doing something also actively in terms of with your robots. Then you have the software on the other side, and some of the software, a lot of could be rule based, and there is software that is machine learning, which is the AI part. And what is deep learning? So I'm now first introducing the concept of deep learning. So deep learning is a small subset of machine learning which leverages deep neural networks, which we'll talk about later in this class, to solve machine learning problems. So typically you have data or external information being detected by the hardware section, flowing across, coming, getting processed by software, and either in some cases the gist or the understanding of this of the final of all that's processed is either saved. Sometimes it's just used and people can just see it, or in some cases, in terms of if you have a robot, this data is sent back to the robots for it to actually do something about it. Okay, so we'll now talk about machine learning types. We'll just talk about machine learning types. Various machine learning types. So to begin with, we have machine learning. You could have them. Are they driven by human supervision? Can they learn incrementally, or how fast do they generalize? These are three ways or three subtypes we can start with looking. Now let's first talk about what is when it has human supervision. So question is it human supervised or not? So there are three methods. One is supervised. In that case, there is some sort of supervision done by human. So as I mentioned before, yes. So a couple of models are trained with human supervision, and some are not. So supervised ones, the machine learning is the one that actually uses uh, supervised data, that's data given by the humans, to make a model. And there are two types of supervised learning. One is classification, and another is regression. So in classification, what we do is that we feed to an algorithm a bunch of some data, and along with that, we give them some labels. And a great example of that is the spam filter. So where we are doing the spam filter in the machine learning approach, what we do is we give it a lot of data, a lot of emails, and we specify. So a human has labeled it and he specify some human has labeled it as, okay, these emails are spam and these are ham. So this labeling has been done, the initial labeling is done by a human, and that is then fed to a computer. So what we're doing right now, so the next what so when the next email comes, the email is then processed by this model, and it gets classified into the two types, either spam or ham. So this is a supervised supervised classification task. So yeah, so this is just a repeat of what I said. You get a lot of it to begin with. You basically have a lot of example emails, which is called training data. So that's the term that's used. It's called training data. Each email is given a label. So the email is the data, and each email is then given a label, whether it's spam or ham. Ham is not spam. It's not the thing you eat. It's just, in this particular case, we're using the word to say not spam. And what the model does is that model learns to model figures of certain patterns in the email, and it kind of internally says that, okay, if these patterns exist internally, it's going to be spam, else it's going to be ham. And what it does later is that when a new email comes in, it just processes it and is able to decide whether that email is spam or ham. So regression, so we talk about classification. So the other type of subtask that's of supervised learning is called is called regression. So in regression, what we do is we don't so in classification it was very simple. You used to say that, hey, there's an email, where is it spam or is it ham? In regression, what we try to do is we try to predict a value. So I'm going to give you a question. So suppose we train a model that you give a couple of parameters about a car. So like, for example, the age of the car, the make of the car, the model of the car, its maintenance history, and if you want to get the price, the current price of the car, would that be regression or classification? Okay. Okay, so that this is a regression task. So if, for example, whenever you're trying to get a value of something, it becomes a regression task. So if you try to get, yeah, that's good. So it's a regression task. I'm seeing a few correct answers coming on chat. So it's a regression task. So if you have a bunch of data and you're trying to get a particular value out of it for a new instance, it's a regression task. Okay. uh, yeah, so like, for example, over here, if you've given a set of features like age, brand, etc., and if you have to predict the price, that's called regression. So to train the model, what we're given is, you'll be like, for example, a, a, a seller of old cars would have a huge database, and they would have a lot of examples with these parameters with different for different cars, different ages, different mileages, etc. And its predictors, or in this case the labels, are the prices. That is the final matter. So, and you the model basically learns to churn in the information like miles, the mileage, age, brand, make, model, etc., and try to predict a price to it, predict the label price to it. So that happens in regression. Okay, so this is something which you've done. So, for example, on the Indian stock market on NSE, you can get access to a lot of these uh, fundamental data, what they call ratios, and using that, you can choose to find. You actually, so this is something I've done personally, and I've figured out there are patterns that with these values you can figure out whether I can I can predict whether I will get a good return, which is like, say, greater than 20%, or whether I would lose money, that's a return less than zero, which is red. So this is something which I have picked up from the data, and we've done that. And there are some intermediate points. So there are two ways of looking at it. If I wanted to predict return using certain set of values, actual predict return. So if I want to say I'm going to get 25% 26%, that would be a regression task. But if I just want to say whether will I get a good return that's greater than 20%, or whether I'm losing money, that kind of becomes a classification task. So depending on the problem, you might choose to have a regression task or a classification task. Okay. So the next type we'll talk about is unsupervised data. So in the unsupervised data, the training data is not labeled. And what the system tries to do, it tries to figure out the patterns without a teacher. Okay, so for example, if you're given this block and it says, hey, group it together, it uses a concept of and wants to cluster it, then it would cluster it together. So say there are a couple of features and you could cluster it together. Okay, so some of the places where you use it is to say detect a group of similar visitors to your blog. And so the trading data is unlabeled and you just feed the data clustering algorithm and it just figures out what to do. So in this case, it kind of figures out that, okay, 40% of your visitors are comic lovers or read the blog in the evening. These are patterns. 40% of visitors are sci-fi lovers and read the blogs in the weekends. So this kind of data helps you target your blog post if that's what you're trying to do. Now, this kind of information is used a lot in digital marketing today for targeting ads to the right people. Okay. So there's another part of this is called hierarchical clustering, which basically tries to bring similar elements before. This is biology's used this for a really long time. The method of classification of animals and plants use the same concept, where they kind of you could put the classification, or you could put the animals in some sort of a relationship like this in a tree and build up a relationship. So these things can actually be built. There's the concept of hierarchical clustering where these things get built automatically based on certain patterns. You could build, so for example, it would figure out what are four-limbed creatures, how mice and rats are similar to each other. We know all this, but even hierarchical clustering algorithms are able to figure out these patterns and put things together in a graph format where the nodes that are most similar to each other are also closest to each other. So another place where this is used is usually for an anomaly tracking. For example, you have a bunch of transactions. So for example, if somebody lives in France and uses their credit card in France or in French e-commerce websites during what's working hours in France only, and if suddenly that credit card gets used, say in Japan, uh, at a completely vague hour, it gets flagged as an anomaly because it doesn't make sense. I mean, there's a usual pattern to it, and it gets accessed as an anomaly. So this is a method that is again leverages unsupervised learning, tries to figure out patterns, and try whenever there's a new point of data set which does not fit in the pattern, it gets highlighted as an anomaly. This is again something which we have used at my IoT company Yatis, where we were looking at RPM and speed from vehicles, and we were looking at fuel efficiency and speed of vehicles. So this is the data which we got, which is RPM and speed. So you can't see this very clearly, but you have RPM on the y-axis and speed on the x-axis. And so you see there's a relationship between speed and RPM, and there are, what do you say, 5 spokes. Can anybody hazard a guess of what these 5 spokes are in a vehicle? And it's something related to speed and RPM. Okay. Can anybody say what this could be? Okay. So these different spokes are gears. Okay. This is technically the first gear. This is second gear, the third gear, the fourth gear, and the fifth gear. And so we actually figured out unsupervised learning techniques to be able to take speed and RPM and figure out these patterns separately. Okay. There's a question that says, will I be covering GANs in this webinar? I'm not covering GANs in this webinar. GANs are covered in the course very explicitly, but we are not talking about GANs explicitly, general in this webinar. So this is how we kind of use unsupervised learning, a real life example, studying speeds and RPMs, and finally being able to do some deep, getting an understanding of how people drive. So this data, we are right now running a project at in certain cities to reduce pollution for on public vehicles using techniques like these. So now we'll talk about something called reinforcement learning. So in reinforcement learning is typically used in what we, as you showed, was used the technique that was used by Mario, by the guys who built the automatic game player. So what is done? It does is it observes that you select an action based on the policies you have, and you act the action, and based the action would either give you a reward or a penalty, and based on the reward or the penalty you would update the policy, which is often called the learning step, and this iteration is done continuously till the most optimum policy is found. Okay, that is reinforcement learning. So as you can see, it's not exactly supervised, not exactly unsupervised. It kind of does a few things together, and it does a few of these things together, and it tries a lot of things and sees what's making most sense and iterates around it to get the best result. And this has been turned out to be a very powerful way, and it's been in a lot of cases. So so as I said, the learning system in is an agent in this context. It's observing the environment. It selects it chooses an action, and either gets rewarded or gets penalty. For example, it's playing a game, it'll get points, and if it does something well, or it dies if it does something wrong. And that's why then it figures out, okay, what should I do when I get this particular result. So in term when I particular so the reinforcement, so I'm talking about Mario, it would figure out that if I just go jump into a turtle, I will die. It figures that out. So it says, then it tries jumping on it. It says, hey, if I jump on it, the turtle dies. So it figures out, okay, I'll get rewarded if I jump on the turtle. And once it's figured that out, it'll keep doing it all the time. So that's how reinforcement learning is working. So there is a lot of applications of reinforcement learning. As you can see, it's used by robots to figure out how to navigate a particular area. DeepMind's AlphaGo, which beat the world champion in Go, Lisa Doll, and finally proved that machines can do a specific task. Was implemented using reinforcement learning. So it basically displayed so many techniques, so many it just kept play it played a lot of different games and just played with itself actually, and just figured out patterns that led to victory. And so what a lot of people said, that a lot of people couldn't figure out a couple of moves at all. They just said that the machine had some figured out certain moves which weren't obvious at all to anyone. It's almost some that felt that the machine had intuition. uh, that is how people explain, how the people who watched when they saw AlphaGo beat Lee Sedol, that's what they felt was happening. Okay, now this next technique we're going to talk about is learning incrementally. So, what happens in batch learning is that the data is given in batches. So, you have a training algorithm, all the data doesn't come together, it's given in batches. The algorithm still stays the same. You study the problem, feed the data in batches, evaluate the solution. In case it's unsatisfactory, you keep doing this over and over again. And once you're satisfied, you launch the program. So batch learning is an So batch learning is offline learning. Huh? So it's not really incremental. So you basically lose all the offline. So it has to be trained offline with all the available data. It takes a lot of time and computing resource. And whenever this training happens, it happens on all available data. So once this system is trained, it just gets pushed into production, and then after that, there is no learning. It just applies whatever it's learned offline. It's learned. Now, how do you train the system with new data? So we cannot with batch learning. You cannot train it incrementally. Every time you have to learn, you kind of have to stop it and build a new data set and kind of train the system from the full data set. That is how you can do it. So once you have trained the model again with the new data set, then you replace the existing model with a newer one. That is how it would happen in batch. So what are the limitations in batch learning? As you can see, every time you have new data, you will have to do retraining again. That takes a lot of computing resources. And if the data is huge, then you have to train everything from scratch, which might be really difficult and very, very time consuming, very, very expensive, because this process of training is a very computationally heavy process. You need a lot of these GPUs, etc., to do it. So you may not really have access to all of it all the time. And if you want to do it every time you get some new piece of data, it's really difficult. So now this new concept of online learning comes in. Okay, so what you do is that you obviously to begin with, you take all the existing data, run batch learning to on top of it, and you run it and you launch it. And post that, what you do is that every time you get some new data, you use that data and learn on the fly incrementally. Okay, this is an online learning system. So basically the system is kind of learning incrementally by feed, and so your new data gets fed in sequentially slowly, and it can also learn and improve the models on the fly. So these are good things when the system of data has a continuous flow, like stock prices, or say the temperature of a certain area, or say the fuel, or the sorry, not fuel, sorry, the the pollution data from certain place, etc. All this information, like it's continuous information, and there you can use online learning to continuously update your model. Uh, so so one method, this is another method that's often used to handle huge data sets. So if you have really lots of data so large that you can't load all of it at one time, you want to do is you want to break it up, and you chop into small pieces and feed that incrementally by one set. That's a way to do it. uh, so that's a nice way to do that, and the system then basically gets trained incrementally on each batch step by step. This is done. Now there's some issues with online learning, is that usually sometimes what happens is that the performance, the quality of the model can decline gradually. This can happen because often bad data is fed in the system. The bad data can come from because there's a malfunctioning sensor, or somebody's intentionally spamming your system. There is some malevolent agents around who want to damage your system if you do that. So online learning cannot ever be just outsourced. You can't say that, hey, I'm going to set it up and then never have to worry about it. I'm just going to keep my feet on top of a table and this just automatically get newer data and learn on top of it. It doesn't really happen. In So humans do need to keep monitoring it. So if anybody's worried that, hey, can the system just do everything by itself and it will essentially just eliminate all the humans for the job, it's not the case. So here the humans then start having a supervisory role, which they need to monitor the system and say that, hey, if does the is the overall performance dropping, or have some sort of overview on what the input data is, and keep removing the anomaly. So the role of the human is becomes a supervisory role, where the machine is able to do a lot more things by itself, but it doesn't really eliminate the need of a human completely. So And now let's talk about something else. It's called instance and model based learning. Okay, so as we had told before, that the basic purpose of machine learning is to make predictions, finally, to make predictions. And so what happens is that you're given a lot of data, either supervised, unsupervised, and then what happens is you get a new piece of data. And the new piece of data, you have to be able to be able to make a prediction on the new type of data, the new data set that's come in. And the true, what you ideally want is that that the model you have is able to perform well on the newer instance. So what you want is you want the model to be able to build a to be able to generalize overall examples, not really specific to one data set, but generalized gets. That is what we ideally want from a good machine learning system. Okay. So question is, how do they generalize? Are they instance based or model based? So now that so that's so in an instance based system, say if you have two types of data, this is a classification task, and you have these training instances, and you have bifurcated them into triangles and rectangles, something like this. Okay, so what you would happen is that you would take your training data, and you would make you would say, and then you could say you got a new instance. Say this is a new instance X. So what would happen in instance based learning is that you would try to find you try to see is it what is its closest to, what is it most comparable to. So look at the existing data set and it says, okay, this guy is close to is close to two triangles and only one rectangle. So this X is going to be assigned to the triangle set. So that's how an instance based learning would work. And the most trivial formats of that are learning by heart. So system also learns by heart, and whenever it sees something, just tries to figure out some similarity and do that. uh, so So a spam filter is also a nice example. So you would basically have a lot of known spam emails, and what you would do is compare your email to known spam emails and have some sort of a similarity index. And if the similarity is if it's similar to a lot of spam emails, you would say that, hey, this is a spam mail. I'm just giving an example. I'm not saying this is what's done. I'm giving an example how you could do a spam filter with in an instance based system. Okay. And what you would have is, so you say if kind of two emails are similar to, so what are common metrics to compare emails? One would be to count the number of words they have in common. So if there are a lot of words in, if they have if say some sort of words, so like for example, we're using credit card free, those are kind of words that they may have in common. And if it says that, hey, you have these uh, if you have these if you have these emails that are similar to known spam emails, I'm going to call it a spam. So that's instance based ones. Now there's a new concept of model based ones. How does the model based one work? So where the model based one works is that you would have a bunch of say you have these rectangles and the triangles, and you have a new instance that's over here. So what a model would do is that model would kind of build up a pattern saying that, hey, this is like the boundary. Okay, so I'm going to take a pointer and I say, so this is going to say is the boundary. This is the boundary between rectangles and triangles. And so if I've got a new X here, so a normal instance based mechanism would say that, okay, this X is closest to two triangles, two squares here, and close to one triangle. So instance based guy would say that, hey, this is a rectangle. But in the model based method, what would say that it would look at, hey, I'm going to build a boundary, and and if this the X, the new instance, lies on this side of the boundary, it's a triangle and not a rectangle. So that's how these two concepts are different. how what model based learning and instance based learning are, how they're different. So normally right now what most people have are model based learners there because they're more generalized and they are more robust. Basically means that it does, for when a new data set comes in, it it does a more accurate prediction. So most of the models today are so most of machine learning today is model based learning. A lot of it is model based learning, and this method of making a prediction based on new data set is called inference. So this is what inference is. Okay, so I'm going to be jumping into the next session, which is machine learning with artificial neural networks. What we will do is that I'm going to answer some questions. So, in case you have any questions, please shoot. I've been watching the question sections, and a lot of these question answers have been done from my team has been answering that. There's a question from Kanan Sri Ram. Is that online learning is happening on a real product or is happening offline on the updates and the updates are being pushed to production? So Kannan, in an online learning is happening on a real product and it's not happening offline. So on the real product is coming, and you get new sets of information coming in, and that information is processed and the system is updated. That's how that works. So it's just happening continuously. There's no training. That's The system could be happening continuously and being updated continuously. That's ideally what will happen in online learning. Okay. Okay, cool. Any more questions? So no questions. I'll just move forward. Okay, cool. Let me just move forward. We'll talk about the next part, which is artificial neural networks, which is like the really new thing that's happening with uh, with machine learning, with what's today really called artificial intelligence. So this is how. So what artificial neural networks are? They were inspired by neurons in the brain. So what neurons in the brain? They look like this, and there's a lot of connections. There are a lot of connections between there are a lot of connections where these are neurons and they get connected to other neurons. So that's how it is. And so they were inspired by biological neurons and animal brains, and we build them computationally in code. That's how it was done. So it's what you have is you have these are what would be the input neurons, which basically just have your input data that's coming as is. This input, the data of this input neuron is gets multiplied by what's called a weight, by a certain number, and gets fed to your next set of neurons. Okay, next set of neurons. So they're basically getting combined together by a certain relationship. And this data would again, you would have a next layer, which would again be a combination or an operation on the weights of the previous layer. So this is a classical single layer neural network, and what you finally get is an output layer. And so what would be is that, so like for example, if you have a picture and you're trying to say whether there are cats or no cats, the pixel values would be your input data, and your final data, you just have like, you wouldn't have four values, you just have two of them, which says cat or no cat. That is how it would work. And the transformations internally, which are decided by the weights that get multiplied to the outputs of the previous neuron, and they get summed over here. So this relationship does that. So okay, so there's a question: is this like, are they like finite state machines? They are similar, but they are one level higher, but they are similar in some ways. You can say they are similar. But state machines are uh, state machines are a little different, but I would say yes, at some point you could see there are similarities between finite state machines and this. But as you go in deeper, you would see how they are quite different, and and they are not, and how they are different. So you'll see that later. Okay. So one nice example of of how a neural network works is done by the example of say having of when you walk into a hotel room and to the bathroom of the hotel room, and you want to finally finalize what's a good value or a good setting for for the tap for hot water for an appropriate temperature you want. Okay, so what do you do usually? Okay, you basically you come to a point, you enter the room, and then you start at a certain point, and then you measure the water temperature, and you say, oh, is this, if it's too hot, what do? You move it to a particular direction. When you move it to that particular direction, you would say, is it getting hotter or colder? So then you would, then if it's getting hotter, then you know, okay, if I move to this direction, it gets hotter. And I wanted, if I wanted hotter, you would to move it, you would kind of say, okay, I wanted much more hotter, so I'm going to move it faster. Or it could be the opposite side. Hey, this water is already very hot and I actually don't want it hotter, I want it colder. Then you would move it in the opposite direction. So what you would do, you would do these iterations a few times, and you would get to the particular value which you're most comfortable with. Okay, and then in the end you get the temperature, you get the output at the temperature you like. So neural networks are also neural networks are also a similar thing, where these, so you, what you could say that there are two inputs, and you have a particular, you have this particular temperature of temperature you like water to be at a particular temperature when you shower. That is, you, that you know is the output, so that's your known value. But what you would do, you would essentially change the weight, so how much the amount of hot water coming and the amount of cold water coming, the rate at which it's been combined to meet it, and you would do that by moving the knob. So neurons are actually quite similar in some ways. It's basically when you move the you would change the weights associated with the outputs of the previous layer till you get the data that is the data that matches your requirement. That is how that works. Okay, so now there's a question, there's a very common question: what is a deep neural, what is deep learning? So a simple neural network is the one where you will have an input layer, an output layer, and what's called one hidden layer. So this layer is called hidden because it's not seen. Externally, you can see the input layer and the output layer, but you can't see what's inside. So this is called the hidden layer. So if you have a single hidden layer, it's called a simple neural network. If you have more than one hidden layer, it's called a deep learning neural network. It's called a deep neural network. So that's the difference. So now who's learning machine? Who's learning machine learning? Turns out that everybody is using machine learning today. Everybody on the internet, the data is everywhere. If you're not using machine learning, you're probably dying. That's, I would say, that is the way it is. So Google Translate, Auto Draw, etc. They are using machine learning. There's this nice link. You can look at that AI experiments with Google. You can go online and see a lot of the examples which Google gives you. There's a nice there's a playground, there's a TensorFlow playground which kind of tells you about how data from different sources are coming in and getting merged at neurons, and you're getting a particular output. This is a pretty interesting demo you could take a look at. This link is given over here, so when you get access to the to this, well, you could even search for TensorFlow playground on your for favorite search engine. You will get that. On the other hand, you could also wait for the slides to get sent to you, and you can try it there also. Okay. Now, what are the deep learning frameworks that we would use? So the deep learning frameworks that we use in famous ones, they are called they are TensorFlow, Theano, Keras, Cafe, Torch, etc. So in our courses, we focus on TensorFlow and Keras. That's what we focus on the courses. They're the most popular ones today. Therefore, that's one of the reasons we focus on. And the other point is that if you learn one of them, it is easy to learn the other. So that's not a big problem. There are machine learning platforms. Uh, so if you're interested in distributed machine learnings, there's Apache Spark MLlib, which is used for distributed machine learning. If you're using simple machine learning on a simple machine, you can use scikit-learn. These are all Python packages. Scikit-learn, NumPy, Pandas. These are packages that get used in that. Uh, So computer vision is one of the big ones, and it's everywhere. That's one of the biggest changes that we have seen. The biggest uses of AI has happened with computer vision, and we're seeing a lot of it everywhere. You can see it on your smartphones. You can see that Google Photos, for example, is automatically able to figure out where you are on which photo. So it's got everywhere. These things weren't available like a decade ago. These are things that have happened so fast, very recently. And yeah, so basically computer vision is basically impacting a lot of things everywhere. So you could be in the medical industry, whether it's in robotics, physics, actually, image processing, optics, pure computer sciences. So computer vision is kind of it's taking everything together and getting, and it's actually hitting everybody else also. So it's getting influenced by everybody, and it's getting used in every field right now. So one of the great challenges that happened before was a challenge called an ImageNet classification challenge. So basically, you had like 1,000 object classes on about 1.5 million images. This was the image classification challenge, and they had like these were the things that you would kind of have to detect and build a model to detect these things. So what computer vision did, so at the beginning of the last decade, so 10 years ago, what you could do, the best model could do a 28% accuracy. Okay, not 28%, the error rate was 28%, which is basically not usable. And over a period of time, so the ImageNet classification challenge ran until 2017. They stopped after that. And they estimated that an average human would have an error rate of 5.1% on that particular set of images. That is what an average human could detect, only so many things. So it's about 95% accurate, what humans would be. And machines already started beating that back in 2015. That's one of the reasons why they're getting so much better and better right now. I'm not saying that machines can detect AR, can see everything better than humans, but on certain use cases, you can train a machine to be a lot better than humans, and that is kind of proven all over a period of time. Okay, so I'm coming towards the end of it, and what we'll do is I'm just going to explain again. So we have a machine learning specialization course which will be launching very soon. It's online, instructor led. We've got both videos and instructor driven courses, so you will be given access to videos, and instructors would be running classes again in the every weekend. The expectations would be you'd be going through the videos and coming to the have some ideas when you come for the instructor sessions, and so you could have really the best of the world, great videos, and then all that information gets reinforced and your doubts get cleared in the instructor session the weekends. That's how we're doing it. There are lots of real life projects, automated assessments, quizzes, access to the data for the entire lifetime, well, certificates, and then there are we'll have support to answer your questions and your doubts. And just because you joined today's webinar, you would have access to this exclusive coupon code, which is valid on all courses only for the next 8 hours. And so we have not shown this anywhere else. And only the people who have attended this webinar have access to this coupon code. So take use of it. It gives you a 20% off on all your courses on CloudxLab. So take a shot at that. Okay, so now what we'll be doing is I would be answering questions, and there are a few. So let's get started. Okay, there's one about a quick demo. I'll do that. Let me do a quick demo. So I'm gonna do is I'm gonna go for a course, and say I look at the basic Linux basics courses, and so this is how it would look like. This is how it would look like. You will have a console on the side. Okay, so this is the Unix console, and because I'm taking up the Linux tutorial right now, and you would have some questions over here, and you would have something that's uh, something to check. So in this particular question, you really don't. It's just a reading exercise. So you just have to mark it complete and move forward, which is what you would do. And then you have some questions, and you could answer those questions, and you could just answer the question and see what the answer is. So is Linux closer to Unix or Windows? What do you guys say? I'll answer what you want. What do you guys say? Is Linux closer to Unix or Windows? Okay, so it is Unix. I'm going to submit the answer, and it's correct, and therefore I get some more points. Right, so that's how this works. This is different lab mode, and so there are questions and answers. Um, yeah, for example, then this is like an exercise in which you're supposed to. This is a simple one. Okay, I'm just starting. I start with something as simple as an Linux. So it's about how to create your new file. So this is, hey, create this file and save it. Okay, so this is an exercise for people who've not. So this is like in case you're starting with Unix. For example, I will just create this file by running this command. So I have created the file and written this commit the command, and I'm going to say submit answer. So what's going to happen is that the command ran over here. It checked whether this particular item existed, whether this file exists, whether it has a right data, and if it is, then it gets checked. So this is how the CloudxLab platform works, and you could learn, and we support these features all the way up to the complicated things like Gans and computer vision, etc. can be tested on this, all the way starting from Linux, Python, Java, you got everything. You got a lot of tools, and we have got a lot of these exercises with which you could do it. I showed you something very very simple, and yeah. Okay, so that is how this is. I'm going to answer some questions. There was a question on from Kannan Sriram of how weights are getting added automatically in. Kannan, so the way the weights get changed is actually based on, technically, yes, reward based system. So you kind of we specify certain metrics, and so you change your weights, and you see whether your metric is getting better or worse. And if your metric is getting better, you say, this is the direction I want to go, and you'll change your weight a step in that direction. Very much like if you're adjusting the knob for water, and you have a certain you have water and you want it colder, and you figure out, if I move it in a particular direction, it gets colder, so you will take one small step in that direction. And that's the same way how weights get changed in a gets changed in for deep neural networks. So it's the same thing happening, but it's just happening at a grand scale, where you could have even a billion possible neurons, and there are the weights and many more weights. So for example, I think we have like GPT-3, which is one of the latest models from on NLP, has about 175 billion parameters to be adjusted. That many parameters, okay? So it's, but what's fundamentally happening, the same thing is happening. You take one step, and you see if it's improving, or if your model is getting better, or is it getting worse. If it's getting improving, you say, that is the direction I want to go, and you take a small step in that direction. and you would then keep doing this over and over again. So this is how that's how the weights get adjusted. Okay. uh, There's a question on the pre-requirement for this training and expectations. So there is for this course. So there isn't. So what we really expect is that for that you guys are honest to yourselves. You know what all you need to learn. So if you really don't know Unix and Python, then we provide the Unix and Python courses. And you then the expectation is that you spend a lot of time in advance learning Unix and Python and getting on speed before you jump into something as complicated like deep learning. So we provide Python and Unix courses. So in case you don't have experience in Unix and Python, what I'd expect is that I would expect you to spend more time to learn Unix and Python in advance, so that, and you could basically do it through CloudxLab. You could just sign up, get access to the to the Python and Linux course, which is self-paced, and you can do it at your own pace and get on speed basically. So once you actually have some experience with Unix and Python, machine learning is not such a big problem. So that is what that's my expectation. That's expectations for this course specifically. Okay. More questions, folks?